Sheltering is one of the most vital components of the human life. The sheltering space provides protection which ultimately gives.
This video is from Laureate Design Lab, School of Design, Art, Architecture, Planning, Consulting and Research.
For the simplification of the study of structure, we can classify all the structure into 5 categories. Typology by geometry. It can be planar and curvilinear. Typology by stiffness. It can be rigid and flexible. Typology by span type. It can be one-way and two-way. Means it can have one-way action and it can have two-way action. Fourth type, typology by material. It can be of any material: wood, brick, stone, concrete, steel, etc. Typology by load carrying action, funicular and bending. So the concept of structure will be talked about keeping in mind all these typological structural system. Based on what we have learned just now, the classification of the structure. So this is the structure made in a software. So typology by geometry, this structure is curvilinear. By stiffness, it is rigid, means it is made up of RCC or material like that. By span, it's two-way, so the action is happening in this direction and in this direction too. That is why by span it is two-way. By material, we can use, or we are using, reinforced concrete cement, RCC. By load carrying action, typology is funicular. So this structure, which is developed in 3ds Max, can be categorized or can be classified based on these 5 parameters into curvilinear, rigid, two-way, reinforced concrete cement and funicular. Means the most important point is that it is curvilinear structure and it's two-way structure and funicular structure. If we further narrow down how to call this structure, so we can call this structure as curvilinear and funicular. By geometry, this particular structure which you can see here, made out of cylinder, is curvilinear. This structure which you can see here is rigid. So by stiffness, it is the example of rigid structure. Now by span, this particular structure, hemispherical structure, is two-way structure because one structure element is going this way, other is going that way or this way. So the structural support is getting rotated on 360 degree. By material, reinforced concrete cement. So this is the example of RCC curvilinear structure. By load carrying action, such shape or such geometrical entity is called funicular. If you hold a piece of paper like this, then it may bend down depending on its thickness. Normal paper will bend down. But if you hold like this, if you are making curvature upward, it will remain like this, and even you can put a little bit of weight onto it, it can handle it. So the upward curvature increases the stiffness and the load carrying capacity of the structure. Curved surfaces can be classified broadly into three categories. One in which you are having split cylinder or the half cylinder. So this will be called as singly curved, wherein this shape is getting repeated throughout. There's another type which is called doubly curved with both curvatures of the same sense, known as synclitic. So this is the example of synclitic, wherein this curvature is throughout and it's in double direction. Double direction means in all direction. It can be repeated many times at whatever angle you want. There's third type which is called doubly curved. This is also doubly curved with the two curvatures of the opposite senses, known as anticlastic. So this is kind of curvature wherein you are getting this particular shape in both the directions, this direction and this direction. So in all these three sketches, you can see the shape is getting repeated in two directions. That is why this is called doubly curved. So altogether, the curvilinear geometry can be simplified in such a way that you can call it as singly curved, doubly curved. In doubly curved you have synclastic and then you have anticlastic. This content is taken from Mainstone, published by MIT Press, Elemental Structural Forms. The curvature of a surface at a point is displayed by cutting it with a plane rotated around the normal to the surface at that point. So this is the normal. A plane line is represented by these dot lines. The curvature varies as the plane rotates, and the curvature is going to vary depending on the type of geometry it is. It may be up or down in all directions, or up in some and down in others. So here it is down, here it is up. The intersection of a dome with a plane passing through its normal has a downward curvature. So the plane which is going through it, if this is a point of the normal of the surface, then this will be called as downward curvature. For a spherical dome, the curvature or the curvatures are all identical. For other types of dome like this, they change from a maximum to a minimum as the plane rotates. The curvature of a dish, this dish, are all up, and of dome all down, are called synclitic. If we call downward curvatures positive and upward curvature negative, domes have positive curvature and dishes are having negative curvature in all directions. Sheltering is one of the most vital components of the human life. The sheltering space provides protection which ultimately gives perpetuation to life. curve is in all natural forms. Nature expresses itself through undulating curved lines. It's not exhibiting Euclidean geometry such as plane and solid geometry. Not only the aesthetic qualities of nature, such as drops of water of rain, but also structural, even functional qualities affect the designer. Thus, the earlier shelters of human beings had their analogies from the nature. Vernacular architecture, which is generally constructed of soil, mud, or some reinforcement into it, is curvilinear in form. For uninterrupted larger space in churches, mosques, halls, auditoriums, and stadiums, designers became more interested in curvilinear forms as a tool for larger span of the space. Today's material science led to new forms of curvilinear architecture. The later part of 19th century brought the Art Nouveau movement with its fluid curvilinear lines. It is important to know that the geometrical forms are only one aspect of structure besides the materials and constructional techniques or the workmanships available or came together to make the structure. Here we will be examining structure through its geometrical configuration. In long span curvilinear structure, the relationship between dead weight, strength, and proportions becomes critical. Let's talk about interdependent threads in the spider web, which are woven together well, can sustain both weight and strength. A cloud, a grain of wheat, a grain of sand, the human body, each is a miracle of structural design. Buildings, as any other physical entity, require structural frameworks to stay safe for habitation, which can be met by curvilinear architecture too. Otherwise, Euclidean geometry is there being used world over. The structure or built-up entity creates space suitable to a particular function. Lightweight wing bones of birds, inspired hollow pipes and sections of steel or steel truss system of structure used to create space for large gatherings at railway stations and airport, etc. In many cases, it is acceptable to use the terms form and structure interchangeably. The term form is more suitable for an entity taken as a whole, whereas the term structure should be used when the whole is analyzed by its components. Therefore, curvilinear architecture can be called both form or structure. Its most parts, if divided by a grid, gives monolithic structural impression. Long span structures can be built using flat construction such as heavy girders, trusses, space frames. However, for spans approximately 30 meters, it is often more economical to build a system made up of curved members. Now, the complexities of curved structure. Main objection to curved structural systems is the complexity or the complexities and difficulties faced during the construction. Visualization of these forms by designers, making of drawings and details, and finally execution. So overall, curved structure gives certain problems of visualization, making the drawing and execution. So that can be sorted by using modern computational software. Architectural form in the 20th century remained linear due to the limitations of hand-drawn architectural drawings, which led to linear buildings that are easily rendered in 2D form. On the other hand, three-dimensional curvilinear form is facilitated by three-dimensional rendering tools by integrating technology. Any form that can be computed by means of digital mediums can now be constructed. There is provision of robotic morphing of the geometry which can be used in architecture, which cannot be possible to morph or carve by hand or by machine. Historical curvilinear structural forms can be counted as arches, vaults, domes, shells, catenaries, pneumatic structures, and some contemporary curvilinear structural forms. Every building should fulfill these following requirements: functionality, safety, and economy, or it can be expanded to stability and equilibrium, strength and stiffness, economy, functionality, finally, not to forget aesthetics.